AlphaFold is an increasingly powerful tool for predicting the structure of proteins and protein complexes using artificial intelligence. However, these are still just predictions, and so along with the predicted structures, AlphaFold provides several measures of confidence in the structures, both at the level of individual amino acid residues or nucleic acid residues, and at the level of the overall structure. Additionally, it provides a level of confidence for each pair of residues and how kind of confident you can be in their relationship to one another, giving you information about how confident the packing of the molecule is and the relative orientation of different subunits in a complex. These kind of three different things are reflected in three different values. The PLDDT score is the residue level score. That's what the structure is colored by. Dark blue is better, orange is worse. You've got the PAE, the pairwise aligned error score. That's where you have the residue to residue. That's depicted in this plot on the side. That dark green is better. Light green is not so good. And then you've got that TM score that's going to be kind of put above the different graphs, and you want that to be closer to 1. So let's go into a little more detail. PLDDT tells you about the residue level confidence, and that's actually what this is colored by. And so the high confidence is going to be in the dark blue, and then the low confidence is going to be in the orange. You can see that the orange, the low confidence regions, these often correspond to what are predicted to potentially be loops or intrinsically disordered regions. Often, even in structures where you have most of it be highly confident, the termini are going to have this lower confidence and be represented by this orange. These values are going to be saved in the B factor section of a file. And so if you were to go and open it in PyMol, say, you could color it by the B factor to get the coloring by that PLDDT, which again is the measure of the residue level confidence. Note too, though, that you have to enter spectrum B red-blue in the command line in PyMol because the scale is inverse for some reason. And then that'll give you the coloring like you see here. So that was residue level. What about overall? So overall, we could tell that this one was a lot more blue than this one. And you can see that this is reflected in this IPTM and this PTM. This is the predicted template modeling score, and this is the interface predicted template modeling score. Bottom line, this is a measure of the confidence in the structure overall, and you want it to be closer to 1. This 0.6 to 0.8 range is kind of the use with caution. If you have lower than that, then you consider it basically a fail, except if you have a really short sequence, and then it's kind of always going to be really low. Over 0.8 is great, and so we've got really close to 1 here, so this is indicating that this is a very confident structure for the most part. Again, with the caveats about those parts that are showing in the orange. Now let's talk about the elephant in this room, the big green thing over here. This is showing you the predicted align error, or PAE. This is a level of the confidence in the relative positions of two residues. It's an indicator that the packing and relative position of the domains is accurate. You want it to be dark green, and when you have areas that are lighter green, that's going to indicate that the relationship between two places is not very confident. To illustrate what I mean, thankfully, they make it easy because these plots are interactive. On the X and the Y axes, you're going to see the individual residues, the numbering of them, plotted out. And so this is saying, okay, if we compare position 222 with position 333, what do we see? Well, we see that they're over here, and we have this white region. And so this is saying we're not very confident in the relationship between these two places. But if we look at something closer to the axes, say, well, here we're comparing things that are really close together, and now we can see that these are actually going to be more confident in their relationship to one another. And so we can see it displayed over here as well as in the sequence. Even with a poorly predicted structure, you're going to see this diagonal line because that's comparing one residue to itself, and then that's going to be very close together. Not only can we see uncertainty in the positioning of the different domains within a chain, so like within a protein, but we can also see uncertainty in the positioning between different subunits in a complex. So this display chain borders, this is showing us kind of where we're differentiating between the RNA and the protein, and then we can do that same sort of pairwise comparison. Again, note that if you have a structure where it's more confident, this is going to be a darker green. And so not only is the structure of these individual residues more confident, but also the relative positioning of these different subunits. As to what it actually represents, so you can see that the values are going to be in angstroms. An angstrom is a measure of distance, that's 0.1 nanometers. And so it's telling you the error between the predicted structure and a theoretical true structure. The smaller the value, the better. The smaller the value, the darker the green. And so the lighter green indicates that there might be some uncertainty in the relative positioning. This could be because the model isn't that good, it doesn't have enough data, or something like this. Or it could be that this region is just really flexible and dynamic, and so there really is no one, quote unquote, right structure. But this software's got to give you something, right? And so they're going to give you typically 5 different structures. When you download the results from the AlphaFold server, you're going to get a zipped folder. It'll look something like this. There's a bunch of different files in here, but these .cif files, these are the ones with the actual structures. And you'll see that there's 0, 1, 2, 3, 4, so you have your model name and then this number. The 0 is the one that has the highest confidence score, and then the 4 would be the lowest confidence score. You could run this again and again in order to get more and more structures, and they should converge on the structure that's most likely to be correct.